So today we are going to solve this problem, profitable stream. So 879. So in this problem there is a group of n members and a list of various crimes they could commit. So the I criminal generate a profit of I and require group of I. So member to participate in it. If a member participate in one crime, that member cannot participate in another crime. So basically you are planning. So in this they are planning crime with a group of members. So you have n members, okay, people available in n means n member means there are people available, and there are different crimes. You can choose from each crimes needs some numbers of member of group of I and give some profit like profit of I. So your goal is we find how many different crime combination you can choose such that total member use must not exceed n and total profit must be at least mean profit. So you can choose any crime or skip any crime, okay, but each crime can be used only once. So order does not matter, only combination matters. So if we have group of people, if we have n is equal to 5 means there are 5 criminals, okay. So there are 5 criminals and mean profit means there is a profit is mean and group of people is 2 and profit is 2 3, okay. So see, this is index 0 and this is index 1 in crime 0, okay. In crime 0, so in crime 0 we need 2 members, so we have that 2 members in group, okay. So we need 2 members and they give profit as 2, okay. In crime 1 we need 2 members and the profit is 3, they give profit 3. So the possible combination is only crime 0 member 2 profit is 2, so it was less than 3, it was less than 3. So in crime 1 members are 2, so their profit is 3, so 3 is valid. And next, if we place crime 0 and crime 1 member is 4, okay, so the profit is 5, so it was valid. So the valid schema is 2. If we have n is equal to 3, so there are 3 criminals, okay, and mean profit is 3 and group is 2, 2 and profit is 2, 3. So crime 0 there was profit is 2, okay, we need 2 members and profit is 2. In crime 1 profit is 3, but crime 0 plus crime 1, so member will be 4, so there are too many members, okay. In this there are too many members, so we have only 3 members, so the total valid schema is 1, okay. If we have n is equal to 1, only one criminal and mean profit is 1 and group is 1, 1 and profit is 1, 1, okay. So in index 0 crime 0 need 1 member, okay, we need 1 member, so that we have in crime 1 we need, in crime 0 we need 1 member and the profit is 1, in 1 we need 1 member and the profit is 1, so the index 0 plus 1 crime 0 plus crime 1 is need 2 people, we need 2 members. So the valid scheme we need 2 members, so it was not possible because we have only 1 member, so the valid schema is 2, okay. So see, you must count how many crime combination give at least minimum profit without using more than n members. So see, so basically we have n members, okay, and many crimes. Every crime need group of I, and profit, minimum profit. Okay, then this is our minimum profit. So count how many way you can choose such that total member is, see, such that total member is less than n and total profit is greater than minimum profit. Okay, so next let's write them in recursion. For every crime we need we have two choice. Okay, if we take crime or if we skip that crime. So the recursion state will be look like this: solve of I, member left, and profit need. Okay, so I is current index. So let's try that. If we have n is equal to 1 and minimum profit is 1, so group is 1 and profit is 1, so index 0. Let's solve 0, 1, 1. So this is crime 0, this one index 0, and this is member 1. We have only one member n, and this profit we need. Okay, profit we need. So let's try that. If we skip this part, if we skip this, it's 1, 1, nothing. If we take this, it's like 1, 0, 0. Okay, so root crime 0, we have two option: skip. First is skip, nothing change. Okay, in nothing change, crime finished, profit still is 1, so it's invalid. In take, member is 1 minus 1 is equal to 0 and profit need is 1 minus 1 is equal to 0. So in this, profit is done, so it was valid. If we had another example, let's take another example. If n is equal to 2 and minimum profit is 1, and we have group if 1, 1 and profit is 1, 0, 1, index 2 members and 1 is profit. Okay, see, if we skip, left side is skip part and right side is take part. Okay, if we skip, nothing will be changed. 1, 2, 1. If we take, it will be like 1, 1, 0. If we skip, if we take, if we skip, it's like 2, 2, 1, and if we take 2, 1, 0, and it was valid. If we skip this 2, 1, 0, if we take 2, 0, 0. Okay, so crime 0, skip option. First is skip option. We have 1, 2, 1. Okay, crime 1, if we skip, profit still 1 only. Okay, if we take member 2 minus 1 is 1, so the profit need 1, 1 is equal to 0, so it's 2, 1, 0. Okay, 0. If we take the crime, so member 1, 2, it's 0, 2, 0. If we take, if we skip, and if we take member 2 minus 1 is 1, we take this crime is 0, index 0, so profit need is 1 minus 1 is 0, so it's 1, 1, 0. So the crime 1, if we skip 2, 1, 0, it was valid. If we take member member 1 minus 1 is 0, so the profit need 0 minus 1 is 0, so the 2, 0, 0. Okay, let's take another example. If we have n is equal to 3 and minimum profit is 2, and group of people we need 1 comma 2, and profit we have 1 comma 2. So let's make a tree of this. See, index 0 and 1, 0, 3 is members and 2 is profit. Okay, if we skip it's 1 comma 3 comma 2. If we take 1 comma 2 comma 1, if we skip 2 3 2, if we take 2 1 0, if we skip this 2 2 1, if we take this 2 comma 0 comma 0. Okay, so index 0 we have 1 2 1 3 2. If we skip crime 1 is 2 3 2, and take crime member is 3 minus 2 is 1. So the profit we need is 2 minus 2 is 0. So it was valid 2 1 0. If we take okay, so remember we have 3 minus 1 is 2, and profit we need 2 minus 1 is 1. So it was 1 comma 2 comma 1. So if we skip 2 by 2 is 1, and take member is 2 minus 2 it's 0. If profit we need it was 1 minus 2 it's 0. So the answer is 2 0 0 0. Yes, so in this what is changing in every node. See, in this what is changing in every node. So it was I member left, left left, and profit we need. It was changing in every state. So let's make a function of this. Okay, let's write a recursion code. See, it was changing in every okay, in every node it was changing. So make function of this. So what we need, int solve of int I in C criminal, C means criminal, in profit we need P N and profit need, and we just call this. Yes, now look the bottom nodes. There are 2 3 2 2 1 0 2 2 1 and 2 0 0. When crime finished, I is equal to size, then check profit need is less than or equal to 0 if it was valid, else invalid. Okay, so if no crimes left, check profit. So it was if crime is less than 0, return 0. Okay, return 0 if I is equal to group dot size return profit net is less than equal to 0 or 1 is to 0. In every node has this option, skip and take. Okay, so I need 2 recursive call. So I know we need 2 recursive call, and that was this skip and take. So let's write down skip option in skip is equal to of C. Right. Let's write down step by step. N is equal to 3, okay, and minimum profit is 2, and group we have 1 and 2, and profit we have 1 and 2. Okay, so at 0 3 2, so let's make a tree of this. If we skip 1 3 2, if we take 1 2 1, if we skip 2 3 2, if we take 2 1 0, if we skip 2 2 1, if we take 2 0 0. Okay, so just look at the nodes. We have 0 3 2 1 3 2 and 1 2 1. Okay, so what is the changing? I change, members change, and profit is changing. Okay, so function will be store these 3 values. Okay, think like that. Function need these 3 values. Okay, I, criminals, and profit need. So I is current index, C is criminal left, okay, and profit, we need profit need. Okay, so next look that lead. See, did you see any node like 1 minus negative 1 and 2? No, na. So means negative number is invalid. So if criminal became negative, so return 0. Okay, in this here, this we are going to return. Okay, next, leave of nodes. See, look the leaf nodes. 2 3 2, it was invalid. 2 1 0 valid, and 2 2 1 invalid, and 2 0 0, it was valid. Okay, it was valid. Okay, now what is common? If I is equal to 2 means criminal finish, crime has finished. So if no crimes left, if profit does valid as invalid. So for this we are going to, if I is equal to group dot size, if profit is less than or equal to 0, return 1, else return 0. Here what we are doing that. Okay, so see, if I is equal to group dot size, if profit need is less than or equal to 0, return 1, else return 0. Okay, next is skips branch. Okay, see, just compare the nodes. 0 3 2 skip 1 3 2, so it's change. I plus 1 other same, so skip is next crime same member same profit. Just next crime same member and same crime. So let's write on code. Solve of I plus 1 criminal same member and same profit. वो profit need. Okay, so just GROUP group and profit. Next, see, now compare take branch. Okay, see, 0 3 2 1 2 1, 0 3 2 1 2 1. So I plus 1. Okay, member is group of I and profit need is profit of I. So taking crime use members and reduce negative need profit. So for this we are going to write like this: in take is equal to solve of I plus 1 group of I and max 0 profit and profit need minus profit of I. Group and POFIT profit. Just a second. See back. Yes. So here, so why we are going to like max 0. So look the tree. We have 2 1 0 and 2 0 0. There is never negative profit, so profit cannot go below 0. Okay, so profit not go below 0, so that's why we use max. Just a second. Now 2 varied leaves we are counting. So total waste is equal to left press right, so we return just skip and take. So just we are going to return skip and take. Return skip press take. Now just return, call the function what is this happening? Profit and group and profit. So it's done. So see why we cannot use pure recursion, because look the tree, there was 1 2 1 and 1 2 1 again 2 0 0 and 2 0 0 again. So same state comes many times. Recursion does not remember result, so it solves same problem again and again. So this is overlapping subproblem. So the tree become exponential. Every crime has two choice, skip and take. So the total calls 2 to the power number of crimes. So if crime is equal to 100, so the crime becomes 2 to the power 100. It was impossible. Okay, so computer will be die. So time limit execute TLE. So it contains big, so group of size is 10 and n is 10, so the profit is 10. So pure recursion explore the tree, runtime becomes extremely slow, so the result is TLE error. Okay, so the stack deep problem also. Deep recursion many function calls, so stack was overflow, especially large input. So for this case only we are going to use memo tabulation dp. So same state if same stage like I see profit comes again and again, so we store the result. We just store the result. Okay, if it's come, then we store this 1 2 1. Next time it's come, we just see I have already solved it, so we just store. If 202, we store once. So that's how we store the result. Okay, so no recursion, just look up, speed become fast. Okay, so what, see in recursion we saw same states come and again. So it was ICP example, this case. Okay, it was also repeating, this was also repeating. So idea is, so just store the answer for each state. Next time we will use result does not recompute subtree. So see what is our state. From tree we decide the state is I, C and profit. So we must store result from this combination. So to store in map, key must be unique. So we make string key like I, C and profit we need. Okay, example like this. So it will be in one string. Okay, so let's write down the code in memorization. First we create a map. String int memo. Okay, next we create a key. Yes, tri in the string key is equal to string I plus 2 string C plus to string profit we need okay. Need. Next we check in memo if memo dot count of key has already stored, just return the result memo of key. Okay, we just return the key. Profit will be same. And next what we do, we just store the result in memo return memo of key is equal to skip and tick. So the function will be over from large new input. We just take memo dot clear so the map is store answer for each state and key creation for, because state has 3 members, so we combine them in one key. Okay, next if we already solve, do not complete again. So after solving subtree, save the result. So see, we use another map to store result of state I, index, criminal and profit need. Before solving recursion, we check memo if result is exit, so we return it directly. Okay, which avoid repeated computations and reduce exponent time. So that's all. Now we convert this code in tabulation. Okay, see, in recursion start from top to go down of tree. Okay, in tabulation start from the smallest case, build answer step by step. So we build dp table, so that we are going to build dp table. Okay, so see, from tree I, C and profit need. So but in tabulation we do not keep index recursion styles. Instead of, we use dp of members and profit. Okay, so what does mean by this? Criminal and this C is equal to criminals used, and P means profit achieved. So value is number of ways. So step 1, we create a table, range of 0 to n, and profit range is 0 to minimum profit. Okay, so for this we are going to create a vector table. Just comment all this. We need this. Come on, okay. Just a second. Okay, first we create a table of vector 2D vector 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 int dp of n plus 1 n plus 1 and vector int mean profit PROFIT plus 1 0. First we create a table db vector 2D vector. Before climb the base case will be see before climb 0 member and 0 profit, one way do nothing, so dp of 0 is 1. Next loop climbs for see for int I is equal to 0, I is less than group dot size and I plus plus. Let's write down both first. Base case 2d dp of 0 is equal to 1 for int I is equal to 0, I is less than group group dot size and I plus plus. Okay, group dot size and I plus plus. So backward loop see same climb multiple time same climb will not use multiple times, so for that we are going to write this for int n c is climb is equal to n and climb is less greater than or equal to group of I and climb minus minus. Okay, and next is profit group. Next is profit group. Okay, profit is minimum profit to profit is greater than or equal to 0, profit minus minus. Next, for not repeat again and again, for this we are going to return for int p is equal to mean profit p is greater than or equal to 0, p minus minus. Next, int new profit is equal to max 0 p minus profit of I profit of I, and next is dp of c and p is plus or equal to this dp of c minus group of I, c minus group of I and c minus group of I and new profit profit. So we just return, just a second. First we make a group of this dp of 0 and 1 base case. Next is for loop. Next we repeat it with does not come, and next is okay, profit of new group. Next into just a second. First go for Travis. Next I have missed one. Okay, just wait. For int c is equal to n and c is greater than or equal to group of 5 group of I c minus minus. Okay, next in profit of profit okay, next is in profit, and next is new profit of I. Next is new profit of I. Let's cut this new new profit of max of 0 and profit minus I. Profit minus I. Profit minus I. Next is we call that is criminal dp. To the dp we have created, we just place minus group of dp of group of I and new profit of I. So it will be 3. So we just return the stored answer and we make a variable and answer. So is equal to 0 for and c is equal to 0 and c is less than or equal to n. C plus plus. So answer plus sum equal to dp of c, and next is minimum profit and just my god, minimum profit and just return ANS. Okay. Oh, it was hard. So this is a sum of all where profit is achieved. Okay, all where profit is achieved. So this is a profit loop. This is a profit loop, and next is crime add wave from previous state. So see, in tabulation we use 2D DP table, DP of member and profit. So we initialize DP of 0 is base case. For each crime we update the table backward to avoid reuse. Each state adds wave from previous members and reduce profit. So finally we are just sum all DP of Timna and minimum profits as the answer. So that's all. Let's submit. Test cases, which one has not passed? So let's correct the code. dp of profit plus or equal to dp of G group of I and new profit. What is the mistake in this code? Let's see which test case is not going true. Runtime sign integer overflow. So what is type of overflow and type value? I think mod is missing. So I was missing a mod. So let me see. If dp of I press 1 so the code was right. I was just not written a constant because it was big. I have to write a constant. Let's write down the constant. Int is equal to and it was base case. Root is was right. Next what we dp of profit. dp of profit is short. dp of timna and profit is equal to dp of c and p plus if you have timna profit and profit just modulo mod. I think now it was right. Answer is equal to answer dp of c minimum profit we have to modulo by mod. Let's see. Almost the code is right, but Submit again. Yes, it's work. See, it was right, but so if you go through this is now minimum profit. Let's see. Okay, so let's calculate the time complexity. So in memorization, in memo, the time complexity is state, I, member and profit. So the total state become climbs into n into minimum profit. So each state complete one. So the time is because of climb into n into minimum profit. So that in tabulation time complexities there are groups for climb, for member and for profit. Okay, so the time is big of crime into n into minimum profit. So the time complexity is same in both. In memorization, space complexity is, so we just store dp of I, member and profit. I just store, so the time complexity, so the space complexity is big of crime into n into minimum profit. So the plus recursion stack is big of for crime. So in tabulation we use dp of member and profit. So space is big of n into minimum profit. In tabulation we use less space, no recursion stack also. Okay, both memorization and tabulation have same time complexity, big of crime into n into minimum profit, but memorization use more space due to 3D DP and recursion stack, in while tabulation can be optimized 2D DP, so it was less space. Okay, so in this code it so I have forgot to use this mod. Okay, so we need mod because the number of streams can become very large and many cases is overflow. So mod is needed because the answer can be become very big. Okay, so you should want to write this in was constant. So see, the code was right, so the mistake is I was forgot to use mod. Okay, so we need mod because the number of possible streams can become very large, which means case integer overflow. Using modulo using this mod. Okay, keeps the value within limit. So yes, so the logic was correct, but I miss applying modulo. I've told that is LE 9 plus 7. Since the number of streams grow exponentially, using mod is necessary to prevent overflow. That's all.